Good morning, welcome to new lecture. Today I will explain how you can find internal force in truss members using section method. Assume we have this truss, which is very simple example. Okay, we have simple truss here in this example. You see from A to B is 6 meters for each span in the vertical direction 4 meter, 4 meter. Joint C is subjected to concentrated load at joint 900 Newton, joint D 600 Newton. For example, I want to find internal force in member BC, this member, using section method. If I want to solve this truss using joint method, you can start from joint B, cut joint B, and write summation of force in vertical direction. You will find DC. Then write summation of force in horizontal direction. You will find DE. Of course, first you should find alpha, this angle. Then if you cut it and write summation of forces in horizontal direction first, you will find DE, because FDE sine alpha plus 600 is equal to 0, so you can find FDE. Then you can write summation of force in vertical direction, for example FDC plus FD cosine alpha is equal to 0. You can find FDC and you will move to another joint. But if we want to find fast, for example, only member DC internal force using section method, how we can find? First, assume we don't have this member. What will happen? If we don't have this member BC, this part ECD, this triangle, will rotate respect to E, and the distance between B and C will increase. That tells us this member BC is subjected to tension force because the distance is increasing. Now, because this part is rotating respect to E, it means you can cut through this member to joint E, one cut like this. You can keep bottom part or top part. If we keep the bottom part, we will need support reaction. If we don't want to find support reactions, so we can look at to the top part. Top part free body diagram. This force is FBC, because this piece, this triangle DEC is rotating respect to E. That tells us, right, summation of moment respect to point E for top side and put equal to 0. If I do that, what I will have? I will have FBC times distance. If this is 6 meter, this will be 3 meter, because this is triangle and this is middle point. So this will be 3 meter. So FBC times 3 rotates respect to point E clockwise, so negative, plus 600 times 4, it wants to rotate that piece respect to point E counterclockwise, so positive 600 times 4. 900 pass through E, so will not create any moment respect to point E, is equal to 0. From here, I can find FBC is equal to 800 Newton. And positive 800 because it is tension. We have tension here in this member. The way I cut it, and I found only with one equation, this member internal force, because I cut it using one section, we call it section method. In section method, for example, I want to find member this time DC internal force. So this time I want to find member DC. Again, remove this member, see what's happening. This rod, this DE, will rotate respect to E. That tells us the distance between C and D will increase. So this is subjected to tension. It is tensile force inside of this member. So if I cut this member through E and I keep top side and write summation of moment respect to point E, summation of moment respect to point E is equal to 0 for top side. What I have, this is F DC. I will have F DC, distance up to point E times 3, rotates this part, this rod, respect to E, clockwise, negative, plus 600 times distance, 600 times 4, because it wants to rotate this part respect to E counterclockwise, so positive is equal to 0. From here again F DC will be 800 Newton. So, now look at the joint C. At joint C, we have 3 members. Look at the joint C, free body diagram, 3 members. One CE, another FCD, another FCB, and we have one external load 900 Newton. This is free body diagram for joint C. From this free body diagram, we can understand FCB is equal to FCD because summation of force in vertical direction is equal to 0. For that reason, I found both of them 800 Newton. 900, you see, once I apply 900, this 900 push this member EC. So the member EC internal force, it is compression 900. So it is negative 900. Here, if I write summation of forces in horizontal direction, I will have minus FCE minus 900 is equal to 0. So from this equation, again, you will find this member internal force, it is 900, and it is negative. It means compression force. Let's look at the next example. Again, we have this truss, and here this force, it is 5 kilonewton. This force, it is 5 kilonewton, 10 kilonewton, 10 kilonewton, Let's see. Four meter, 4 meter, 4 meter, and this is again 4 meter. We have this truss. For example, joint A, B, C, D, E, F, and G. I want to find internal force in different members. For example, let's start member FD. Member FD, this member. If I want to find internal force in member FD, using section method, I will remove that member. What will happen? Top side, top triangle, you see it is rotating with respect to point E. And how it will rotate? This 5 push this triangle from left to right, and it will rotate respect to E clockwise. So the distance between F and D will increase. So that tells us there is a tensile force here. So if I cut this and F force FD and keep top side and write summation of moment only for top side. For respect to point E, I will have FD times 4. It wants to rotate this triangle respect to point E counterclockwise, so positive. Minus 5 times 4, 10. You see, this force is passing through E, will not create moment. Respect to point E, 5 will not create any moment respect to point E, so this is equal to 0. From here, I can find FD is equal to 5 kilonewton, and it is tension. Now, okay. For member, for example, DB, I want to find member DB internal force. This member. If I remove that member, what will happen? Top side will move in horizontal direction from left to right. Top side will move in horizontal direction from left to right, and this is square shape ADCB panel will deform like parallelogram. It will be like this. So you see the distance between D and B, it is decreasing. That tells us internal force in that member, it is compression force or compressive member, and because it moves in horizontal direction, we will cut this panel in horizontal direction. So we will cut 3 members which they are not parallel, 2 of them parallel of course, but all 3 they are not parallel and they are not concurrent in one point. I will cut like this. If I cut and draw free body diagram for top side. Free body diagram top side means I have this part, top part, and the arrow direction I show in the tension direction goes out of these joints, you see. Now this angle, it is 45 degrees, we know that, because for this triangle tangent alpha is equal 4 divided by 4, so it is 45 degrees. For this top side, in order to satisfy equilibrium equation, I can write summation of forces in horizontal direction equal to 0. So this member force, it is F dB. So it will be F dB, component in the horizontal direction, cosine 45. So I decompose this force in the horizontal and vertical direction. The component in the horizontal direction, it will be F dB cosine 45 plus 10 plus another 10 plus 5, all of them from left to right, is equal to 0. From here, F dB will be equal to 25, negative 25, 10 plus 10 plus 5, negative 25. If I take the other side, divided by cosine 45. Negative means the force, internal force, it is compression force, or it is compressive member. So the magnitude, it will be negative 25 divided by cosine 45. Now, let's see another member. For example, I want to find internal force in member EC. What I will do, first step, remove that member. What happens? This piece, you see. If you remove the member EC, will rotate respect to D. In which direction it will rotate? Clockwise. If this piece rotating clockwise respect to hinge D, what will happen? The distance between E and C will decrease. So point E and C comes closer to each other. The distance is decreasing. This means there is a compression force in this member. So FEC, I will cut this member through joint or hinge D, and I will keep top side. You can keep bottom side, but in that case you will need first find reaction, because we don't have reaction. Reactions unknown. Always you see I'm keeping top side. This makes calculation faster and easier. If I write summation of moment respect to joint D, what I will have negative FEC times the distance 4, FEC times distance up to point D. In the perpendicular direction it is 4, and because it is rotating clockwise, negative, plus 10 times 4, minus 10 times 4, because again it is clockwise, minus 5 times 10 times 4, 5 times 8, minus this 5 times 4 is equal to 0. So I want to find internal force in this member. From beginning I know it will be under compression, so the answer should be, final answer should be negative, because this part rotates respect to point D. I'm writing summation of moments respect to point D for top side. FEC times 4 negative, minus 10 times 4, minus 5 times 8, minus 5 times 4 is equal to 0. So from here, one equation, one unknown, you can find FEC. Okay. For your homework, solve these trusses using joint method and section method, both method, and compare the answers. First example, it is very simple. A, B, C, D, E, F, 2 meter, 2 meter, 1.5 meter. Here I have 8 kilonewton. Here external load 4 kilonewton. Find internal force for member BC, for member EF, and for member CF. At the same time, find zero force members. So this is your homework problem. You have this truss, 8 kilonewton, 4 kilonewton, joint A, B, C, D, E, F. Find internal force in member BC, EF and CF, and find zero force members for this. And solve this truss using two different methods. One of them is joint method. You will first find reactions and then you will cut joint by joint, and you will start from that joint. We have only two members, two unknowns. Find zero force member. Use those tricks I explained last session and find zero force member. And then solve using section method and compare your answers. So this is one problem. Another problem this one. This truss. A, B, C, D, E, F, G, H, I, J, K. External force at joint B, 1500 pound, C, 1500 pound, D, 1500 pound, E, 1500 pound, and F, 1500 pound. This height, it is 4 feet, and the length for each span is 3 feet, all of them 3 feet. Find internal force in member HG, member BC, member HE, member JK, using section method. So you have this truss. You see each span length it is 3 feet in horizontal direction. Height of truss it is 4 feet. Joint B, C, D, E, F is subjected to concentrated load at joint. Each one is 1500 pound or 1500 pound at joint B, at joint C, D, E, F. I want you find internal force for member HG, DC, HE, JK. Next one. Okay, we have this truss A, B, C, D, E, F, G, H, I, J, K, L. Each span length in horizontal direction, it is 2 meters. So 2 meter, 2 meter, 2 meter, 2 meter, 2 meter, 2 meter. In the vertical direction, 2 meters, 2 meters, again 2 meters. External load. External load kilonewton, 20 kilonewton, another 10 kilonewton. So at joint C 10 kilonewton, at joint D 20 kilonewton, at joint E 10 kilonewton. First step, find zero force members. So find zero force member first for this truss. Then find internal force in member AB, for member BL, for member LC, for member LK, and for member CD, and even for member BC, using section method. So first find zero force members for this truss, then find internal forces in member BC, AB, LC, BL, LK, and CD. Use section method and apply section method the way I apply. First remove that member, then visualize the system, see what is happening. If you remove that member, definitely your structure will be unstable, because this is simple truss and it is not indeterminate structure. It means if you remove one member, the system is definitely unstable. Unstable means it will deform. Visualize that deformation. See, for example, top side, how it moves. It is rotating, it is moving from left to right, it is moving from up to down or something like that. Then cut through that member and that joint the way I explained, and see the member it is subjected to the tension or compression, and write equilibrium equation and find internal forces. These are your homework problems for next session. Of course, I will review this, I will solve these in different lectures, but try first, think about that, try to solve yourself, then I will solve and you will compare your answer. Thank you so much for watching this lecture. See you next session. Bye bye.